Milan, be in the diagram below, we've got ADC represents a horizontal triangular field. When they talk about horizontal triangular field, I just want you to look at the room that you're in right now. So the floor will be the horizontal plane, okay? And they said BD represents a vertical building standing on ADC at D. Now, check the corner of wherever you're sitting. There, at that corner, basically the vertical straight line from the top of the ceiling to the bottom of the floor. So that line is similar to BD. However, you will notice that that space, the walls, represents what we call the vertical plane. So the floor is the horizontal plane and the walls are your vertical planes. They both connect at a corner, which is the bottom of the corner that I asked you to choose and the top of the corner that I asked you to choose. And the top of that corner between the wall and the ceiling is B, and the bottom of that corner, which is between the wall and the floor, is D. Okay, I just want you to think of it that way. And they gave us that DAC is alpha and ACD is beta. Then they said the angle of elevation of B from A is theta. And they gave us AC. And AC, they said, is 120 meters. So I'll just put it in my diagram. All right. And I will look at this in the next slide thoroughly and label everything. They want us to determine BD, which is the length of that corner that I ask you to choose in that room that you're sitting in. And basically they want the height of that corner. How long will it be? The length, or I just don't want to say it's the length, it's the height, which is from the bottom, which is the floor, to the top, which is the ceiling. So that height, what will it be? And we have to determine that height in terms of alpha, beta, and theta. As I've said, think of the green part as the floor, as I've indicated. So I'll be focusing on that green part where I know that AC is 120. And when you look at that triangle, you are given DAC, angle DAC, which is alpha. You're also given angle ACD, which is beta. You are missing angle ADC, which when we calculate it later on, you will notice that you will learn that it will be 180 degrees minus alpha and beta, which is interior angles of a triangle. The angle of elevation, when you look horizontally up, so when you look horizontally up, that will be the angle of elevation. So when I look horizontally from A to D and I look up to B, it will create an angle of elevation, which is theta. Okay. If I look horizontally from A to D and down, then there will be an angle of depression, of which we do not have in this case. I know some of you might say that alpha is an angle of depression. No. Remember that theta lies on the wall. That is a vertical plane. And alpha lies on the floor. So they're not in the same plane. Are we together? They are not in the same plane. Now, once I have done that, I will just show you everything that I need in essence. I need 80. The reason why I need 80 because I just want to show you that I need to calculate BD, right? And for me to calculate BD, it's either I use triangle BDC or I use triangle BDA. But I'm going to choose triangle BDA. Why do I choose triangle BDA? It is because I've got an acute angle which is theta. Therefore, since I want to use that triangle, I will need to calculate a common side between the vertical plane, and in the vertical plane we've got triangle BDA, and the horizontal plane which is triangle ADB. The common side between those two triangles will be AD, and I will fight by all means to calculate AD. But here's the thing, between the horizontal plane, which is the brownish plane that I just highlighted, which is triangle BDA, and the green part, which is the floor, which one do you think has sufficient information to enable us to use either the cosine rule or the sine rule or any of the ratios? Note that you can only use the ratios if you have a right angled triangle. You're right. The green triangle is the one that has sufficient information because we've got three angles there and we've got one side. And why do I say it has sufficient information? It will enable us to use the sine rule, because for you to use the sine rule, you just need one pair of opposite angle and side that must have the values and one angle. And then that will enable you to calculate the other angles as well as the other sides. So I am going to focus on triangle ADC. And as I've said, triangle ADC, I will start with this triangle as it has sufficient information to allow me to use the sine rule to calculate any side I want. Now, in that triangle, when I take alpha and add it with beta and add it with angle ADC, it should give me 180 degrees. That will be sum of angles in the triangle. And if I solve for angle ADC, I will end up having angle ADC being equal to 180 minus the sum of alpha and beta. Now that I have that, you will notice that you've got an angle and the opposite side and two other angles. So I can simply use the sine rule, to calculate either AD or DC. And as I've said, I will calculate AD because that AD will enable me to use that brownish triangle which is on my vertical plane. And when I calculate AD, I will use sine rule. So I'll say AD divided by sine of beta will be equal to AC divided by sine of ADC. So this divided by sine of that equals to AC divided by the sine of the opposite angle, which will be 180 minus sum of alpha plus beta. Now, since I've got this, for me to be able to solve for AD, I need to get rid of the denominator of AD, which is sine beta. And to get rid of that sine beta, all I am going to do is to multiply both sides by sine beta. And when I multiply both sides by sine beta, this will cancel with that. Therefore, I'll be left with AD being equal to everything else. But I highlighted the denominator there because I can simplify that using reduction formula. Now, if you've been watching this videos on this question paper from question 1, you will note how I actually deal with reduction formula. I will normally put 180, so I know that 180 is between the second quadrant and the third quadrant. And the fact that I'm minusing means that from 180, I'm moving from 180 anti-clockwise. Actually, not anti-clockwise, but clockwise. Okay, so I'm moving from 180, minus means I'm moving clockwise. And when I move clockwise, that leaves me in the second quadrant. Okay, I'm currently looking at my clock right now, and for me, 180 is on quarter to, right? From quarter to, it will move to either 5-2 or 10-2. So it's in the second quadrant. And in the second quadrant, sign is positive. Therefore, that will simply give me sign of alpha plus beta. Okay. And when I simplify that denominator, I'll just get sign of alpha plus beta. That is what AD will be equal to. I'm done with that green triangle. I'm done with my horizontal plane. Now I'm going to move to the wall. Okay, I'm moving away from the floor. I'm moving to the wall now, which is my vertical plane. Now, question is, does my vertical plane have sufficient information to enable me to calculate BD? This is nice. Let's see. All I know is that in that triangle, I've got AD. And what is AD in that triangle? First of all, I indicated that triangle, which is BD, which is ADB or BDA, all right? It is a right-angled triangle. It is a right-angled triangle. And since it's a right-angled triangle, you can actually use sine, cos, or tan to calculate a side in relation to theta. That's why I chose that angle, because it has an acute angle, which is theta. That's the only reason. But here's the thing. I want BD, but I've got AD in that triangle, which is adjacent to theta, and BD is opposite theta. And from the ratios I listed above, you will notice that the only ratio that has adjacent and opposite is 10. And tan theta here will be opposite over adjacent. The opposite side will be BD, and the adjacent side will be AD. But that AD, we've calculated it. That AD is equal to 120 sine beta divided by sine of alpha plus beta, which is a compound angle. And therefore, if I want to solve for BD, all I did was to multiply both sides by 80, like I've done in the previous slide. I will end up having BD is equals to 10 theta times AD. But AD is 120 times sine theta divided by sine alpha plus beta. That's it. Once you get here, you're done. Now, they said you must simplify your answer. So I changed that 10 theta to sine theta over cos theta, meaning that my sine theta will be in the numerator, my cos theta will be in the denominator. The only thing I did not simplify it is that sine of alpha plus beta, which is my compound angle. So just expand it. Remember to put it in brackets when you expand it. And therefore, that is what BD will be. BD will be that whole expression with it. easy peasy, lemon squeezy. All right, try out question 11, and these are the questions that you need to answer. With respect to C, when you look at the question paper, you will notice that they made a mistake by writing the coordinates of D as -10 and -3. That is incorrect. It should be -10 and 3. Okay, please use the one that you see in this video. Thank you for watching, and please don't forget to subscribe, like, and share with your friends in all your social media platforms. Thank you for watching again.